Good morning, everyone. This is the Q&A session 12 from the chapter of electric charges and field. The topic is motion of charge in an electric field, and this session is in continuation of the session number 11, in which we have studied about the deflection of a charge when it moves under the influence of an electric field. So in the previous session, we have derived the equation for the deflection of a charge which was moving in an electrical field whose direction was perpendicular to the direction of the motion of the charge. So, so based on that session, I have taken this question for the session number 12. The question is, an electron enters the region of a uniform downward electric field with a uniform horizontal velocity of 5 into 10 to the power 6 meter per second. It leaves the region after traveling a distance of 20 centimeter. So in order to save the time for this session, I have already drawn a small diagram here in order to explain this question. Now in this question, this is the region of electrical field. This is the region of electrical field, and the electron enters this. This is the region of electrical field, that is this one, and the electron enters, let us say, at this point of this electric field, and I have denoted this point as O, and it moves under the influence of this electric field, and it exit the electric field at the point C. Now here, as mentioned in this question, the electric field is the direction of the electric field is downward, as it is indicated in this diagram, and the electron enters this region at this point O, and it exits this electric field region at the point C, and then it hits the screen. This is the screen. This is the screen, and it hits the screen at this point A. And when it hits the screen at this point A, the deflection of the electron is equal to 4 centimeter, which I have already mentioned it here. That the deflection is equal to AB, and which is equal to 4 centimeter. The electron is moving with a uniform horizontal velocity, so electron enters this field in this direction, where I have already marked with an arrow. So this is the direction of motion of the electron when it enters the electric field. Now when it enters the electric field, it is the vertical component of the velocity of this electron is 0. When it enters the electrical field, and as it moves in this field, then it will develop, or it will gain a vertical component, and because of the electrostatic force, the electric field is the direction of the electric field is downward. So because it is a negatively charged particle, so therefore the electrostatic force will be acting in the upward direction, that is in the opposite direction of the direction of the electric field. So because of this electrostatic force, this electron will get deflected, and it will exit this field, say at this point C. So this path, that is OC, or you can say the motion of the path of this electron, it will be parabolic, or you can say this curve OC will be parabolic. So this we have already studied in the previous session, that is in the session number 11. So but when it leaves this electric field region, the this is the point of exit of this electron from this electric field region. So when it leaves this electric field region, it will be having two components of velocity. One is the horizontal component, which is equal to 5 into 10 to the power 6 meter per second, and at the same time it will also gain a vertical component. So here when it leaves this electric field, now it will not be following a this parabolic path, because in this region, that is, this screen is placed at a distance of 10 centimeter from the region of this electric field, that is where this screen is placed at a distance of 10 centimeter from the region where this electric field means this is the region, this is the electric field region of 20 centimeter, and after that, that is from this point, you can say from the point C, where this electron is leaving this electric field region, the screen is placed at a distance of 10 centimeter from this point C. So here when it leaves this electric field region, the electron will follow the path or which will be inclined at an angle theta with the horizontal, because now it is not under the influence of the electric field. So in this case, we can now calculate, first of all we'll calculate the vertical component of the velocity. So for that we will be using the equation of motion. The equation of motion क्या क्या है? तो v is equal to u plus at होता है, एक होता है आपका s is equal to ut plus half at square. ठीक है? So now in this case, if I use this equation v is equal to u plus at, so v will be equal to at, because the initial vertical component, the initial or you can say the initial vertical component of the velocity of the electron is 0. So v will be equal to at. And what is t? T is the time taken by this electron to reach this point C. Okay? So second point is, now let us consider this initial this horizontal uniform velocity of electron as u. If I am taking it as u, then it is equal to 5 into 10 to the power 6 meter per second. Now from this triangle, A, E and C, A, E, C, from this triangle we can get this tan theta is equal to A, E upon CE. So A is how much? The deflection of this electron when it strikes the screen is 4 centimeter, and I have taken these the deflection of this electron when it exits the electric field as y. So AE will be equal to 4 centimeter hai, that is minus y. So I will be converting this 4 into meter. So this will be equal to 0.04 minus y divided by, it is this CE is equal to 10 centimeters, so that is equal to 0.1 meter. Now this will also be equal to the horizontal component of this velocity is u. I have already mentioned it here, and the vertical component of this of the velocity of the electron is v. So that can also be, tan theta will be also equal to v upon u. So this is equal to v upon u. So it implies that now y, this is the deflection of this electron at this point C, that is at the point where the electron is exiting the electric field. So y will be equal to ut, s is equal to ut plus half at square. Now initial vertical this component of the electron velocity is equal to 0. So y will be equal to half at square. ठीक है ना? Because u is the initial vertical component of this electron. U is the initial vertical component of the velocity of the electron. So this is 0, so y will be equal to half a t square. So now I will be substituting this value of y in this equation. So this will be equal to, so y is equal to half a t square. So I am now just rubbing it here. So that is equal to 0.04 minus y divided by 0.1, which is, sorry, this is equal to minus half at square. ठीक है? Minus half at square, which is equal to v upon u. Now v is equal to at upon u. This is the equation which I have got. So now I will be cross multiplying it. So that will be equal to 0.180, which is equal to 0.04 u minus u by 2at square. I got this equation by cross multiplication. So now what I will do is, I will now take this component on the left hand side, and I will take this component on the left hand side, then I will be getting as 0.180 plus u by 2 at square, which is equal to 0.04 u. Okay, now from here I can what I can do is now that here A can be taken um, now I will write it here. Now here one more thing. The velocity of this electron in the horizontal direction is equal to is I have taken it as u, and the time so the time taken by this electron to cover this region of electric field will be equal to time is equal to distance, that is equal to 20 centimeter, which is equal to 0.2 meter divided by u. Okay, where u is the uniform horizontal velocity of the electron. So I will be substituting this value here of t in this equation. So I will be getting as 0.1 t. T is equal to 0.2. So I will 0.2 divided by u. So this will be equal to 0.02. 0.02 A अपॉन u प्लस t की वैल्यू हम पुट करेंगे 0.2, so that will be equal to u by 2 a, and this will be equal to 0.2 u whole square I will just write the value of t here as 0.2 divided by u. Yeah. And this is equal to 0.04 u. So now it implies that अगर हम इसको solve करेंगे इस equation को, then I will be getting 0.02 a divided by u plus this will be equal to 4 by 0.04 a divided by 2 into this is u square, and this one u will get cancelled out, and this is equal to 0.04 u. So finally this I will be getting as 0.02 a upon u plus 0.02 a upon u, which is equal to 0.04 u. So yeah, so solving this, what I will be getting is it will be 0.04 a. Since I will be taking the, if I take the LCM, then this will be equal to 0.04 a, and you will go on the right hand side of this equation, and it will be equal to 0.04 u square. So finally what I am getting, it implies that the acceleration is equal to u square, because this will cancel out. Okay, so the acceleration of this electron will be equal to u square, and u the value of the u is given as the value of the u is 5 into 10 to the power 6. So a will be equal to 5 into 10 to the power 6 whole square, which is equal to 25 into 10 to the power 12 meter per second square. So the acceleration of this electron, the acceleration of this electron A is equal to 25 into 10 to the power 12 meter per second square. Now deflection. The deflection of the electron when it leaves the electric field, so deflection is equal to y, and y is equal to half a t square. Okay, a we have found, and t is equal to 0.2 upon u. So what I will do is, I will find the value of y, which is equal to half. Acceleration is 25 into 10 to the power 12 into t square. T square is equal to 0.2, that is equal to 0.04 divided by u square. U is equal to 25 into u is given by 5 into 10 to the power 6. So this is equal to 25 into 10 to the power 12. So y will be equal to half, this will cancel out. So half into 0.02. So this is equal to 0.02 meter. So the deflection of this electron at the point of exit of the electric field is equal to 0.02 meter, or y is equal to 2 centimeter. That is, this deflection is equal to this y is equal to 2 centimeter. Okay, so we have calculated the deflection, that is the first part of this question, that is the deflection of the electron when it leaves the electric field is equal to 2 centimeter. And now we have to find the magnitude of the electric field. Now here I will be writing this. This is the deflection which we have already calculated. And now I will be calculating the value of the electric field, or the intensity of the electric field. So for that, I will be using the formula that acceleration of the electron is given by QE upon m, which we have already studied in the session number 11. So now A we have already received, that is acceleration was equal to, we have calculated the value as A was equal to u square, which was equal to 25 into 10 to the power 12 meter per second square. So I will be putting this value here as 25 into 10 to the power 12. This is the charge of this electron, which is equal to 1.6 into 10 to the power minus 19 coulomb. We have to find the value of E divided by mass of the electron. So the mass of the electron is given in this question, which is equal to 9.1 into 10 to the power minus 31. So E will be equal to 25 into 10 to the power 12 into 9.1 into 10 to the power minus 31 divided by 1.6 into 10 to the power minus 19. So this is the value of this electric field. And so we have to now solve this equation. E will be equal to 25 divided by 1.6 into 9.1, and now this is 10 to the power 12, and this 10 to the power 19, when it comes into the numerator, it will become equal to 10 to the power 30. That will be equal to 10 to the power 12 and plus this one. This is equal to 9 to 11, 31 into 10 to the power minus 31. So this is equal to, this will cancel out. So I'm getting the value as 25 into 9.1 divided by 1.6. This is equal to 142. So the intensity of the electric field is equal to 142 newtons per coulomb. 142.187. 0.187 Newton per coulomb. So in this way we have solved this question. So we have calculated three things here. That is, the acceleration of the charge was 25 into 10 to the power 12 meter per second square. The value of this intensity of electric field is equal to 142.187 Newton per coulomb. And we have also found the deflection of this electron at when it leaves the electric field, which was y is equal to 2 centimeter. Okay, so these were the three important things which we have found in this equation. So thank you very much for joining this session. I hope you have understood the solution of this problem, and in the next session I will be coming up with some more questions, and those questions will be from the various engineering entrance examinations which are conducted every year in India. So thank you very much for joining, and have a nice day. Bye.